Hello, in this lecture, we are going to take our previous lecture forward in which we were discussing ordinary differential equations. So kindly give me a minute and meanwhile, I'll share the screen. Okay, just give me a minute. Okay. So we were having this discussion on ordinary differential equation yesterday, and we'll take it forward from there itself. Okay. I hope the screen is visible. Okay. So, the discussion that we were doing was pertaining to first degree differential equation, right? First order, first degree differential equations, and we were doing it in a manner of problem solving. I'll teach you a separate lecture on more on physics side, but first let us discuss things more related to mathematics and at least solving part. So let us start with another question today, and this is again asked in net examination only. Okay, so this is asked in net examination for mathematics people. Yeah, simple question. That's why I'm sharing it with you. So it says that let y1 and y2 be the solutions of dy upon dx equals to y plus 17. And further it says that the conditions are that y1 0 is equal to 0 and y2 0 equals to 1. Then option number A says y1 and y2 will never intersect. Then option number B says y1 and y2 intersect at x equals to e. Option number C says y1 and y2 intersect at x equal to 17. And last option is y1 and y2 intersect at x equal to 1. So this was the question that was asked. Let us try to do this particular question. Okay, let us try to do this particular question. Now, how to solve this particular question? Let us see. So I know that y1 and y2 will never intersect. Y1 and y2 will intersect at x equal to e. Y1 and y2 intersect at x equal to 17. And y1 and y2 intersect at x equal to 1. How to solve this particular differential equation? I know this is the first order, first degree differential equation, that is dy by dx is given by y plus 17, right? So if this is the case, what I can do, I can find my integrating factor. Integrating factor would be e to the power minus x. I think this is quite clear. This is minus 1. Integrating factor would be e to the power minus x. I hope it is clear. And if I write y is equal to e to the power minus x is equal to integration 17 e to the power minus x dx, what I will get? I will get simply y into e to the power minus x minus 17 e to the power minus x plus some constant of integration. Is that clear? I hope यहाँ तक किसी को दिक्कत नहीं आ रही होगी. Now
No,
there
sir.
are two, okay. Now there are two solutions given, so I'll write it as y1. I can write it as some k1 e to the power x minus 17. I've placed this e to the power minus x downwards, and y2. Another solution that is given, I'll write k2 e to the power x minus 17 because there are two different conditions given. Since there are two different conditions given on y1 and y2, so I'm writing these constants as some different values. So C I'm writing k2 for y2, and C I'm writing k1 for y1 solution. Okay, now the given conditions are that y1 0 should be 0 and y2 0 should be 1. So if y1 0 is 0, what does it imply? It implies that your k1 should be equal to 17. Okay, and if y2 0 is equal to 1, it implies your k2 must be equal to 18. Okay, you just write here 1, your e to the power 0 is 1, k2 minus 17, so k2 would be 18. So these are the values of k1 k2. So there are two solutions now. According to the given conditions, there are two solutions given by so it says that both of them are solutions, right? Both of them are solution. One of them is passing through 0, 0, another one is passing through 0, 1. Now it says that these two solutions, if they're formed, will they intersect with each other? Okay, intersect means at least there should be one common point on the locus. So both of them are lines. I'm not making it like it is wrong because it is passing through origin, but I'm saying that if there are two lines, if I'm saying that they intersect each other, at least one point should lie, one put should lie on both of these locus. Okay, one point should be common in both of the locus. Okay, so that is one thing. So what is y1x? So y1x, I can write it as 17 minus 17 e की power minus x. And what is y2x? Y2x, I can write it as 18 minus 17. No. Sorry. I think it was my mistake. Sorry. So y1x would be 17 e की power x minus 17, and y2x would be 18 e की power x minus 17. Now, if let us consider that both of them intersect at point x naught. Let us say that both y1 and y2 intersect at point x naught. What does it imply? It implies at that particular point your y1 x naught should be equal to y2 x naught. And that would indeed imply that 17 e की power x naught minus 17 should be equal to 18 e की power x naught minus 17. 17 gets cancelled. It implies this particular point would be a solution of e की power x naught equal to 0. Okay. Do you think that there would be some real solution to it? I already taught you on the very first day that exponential is always a positive function. It can never be 0. So that implies there exists there does not exist any such x naught belongs to R such that e की power x is 0, since e की power x is always greater than 0 for all x belongs to R. Okay, so for all x belongs to R, my exponential function is always positive. That is, it is always greater than 0, so it cannot be equal to 0. It implies these two solutions will never intersect each other. Is that clear? Should I repeat it all over again? Is that clear?
एक बार रिपीट कर दो.
Okay, so देखो दिया क्या था? Let y1 and y2 be the solutions of dy by dx equal to y plus 17. दो initial conditions दे रखी थी. मतलब you were given one differential equation and you were told कि if there are two solutions to it, means if it passes to 0, 0, or if it passes to 0, 1, what would be the complete solution? And that complete solution is given by y1 and y2. And now it has been asked that y1 and y2 will intersect at some point or will not intersect at any point. So the question given to you was that if y1 and y2 are the two solutions of dy by dx plus is equal to y plus 17, and there are two initial conditions given to you. Accordingly, there are two solutions corresponding to these two initial conditions. Now it has been asked that according to this question, according to the initial conditions, whether these two solutions would intersect or not. So what we have done, we have solved this differential equation, and we found that while we were solving it, if I was placing the first initial condition that y1 equal to 0, the solution was 17, because k1 is 17 e की power x minus 17, and y2, the second solution would be 18 e की power x minus 17. So this is 17 e की power x minus 17, this is y1, 18 e की power x minus 17 is y2. Now it says that y1 and y2 will intersect, will not intersect, all those things. So if at all there are two curves which are intersecting, then there must be at least one point which lies on both of these locus. Okay, so इंटरसेक्शन का मतलब क्या होता है? अगर दो कर्व्स इंटरसेक्ट करें किसी पॉइंट पे, इट इंप्लाइज ये पॉइंट दोनों में कॉमन होना चाहिए, राइट? सो दैट इज व्हाट आई हैव डन. I've thought that let these two intersect at point x naught. If they intersect at point x naught, then 17 e की power x naught minus 17 should be equal to 18 e की power x naught minus 17, and which would imply e की power x naught has to be 0. Now, on the very first day of the curve sketching, I've told you that e की power x is always a positive function. You see, there is no such intersection on x-axis. It will go on becoming as close as possible to 0, but it can never be 0 itself. Okay, so it is always positive. You can see that it is always lying above this x-axis only. So it is always lying above the x-axis, and it will never intersect x equal to 0. Okay, y equal to 0. That is the x-axis. So it is always positive. So exponential function is always positive. So there cannot be any such real number such that e की power x naught is 0. That implies y1 and y2 will never intersect each other. Because had it been some unique point, let's say E, then I would have said that y1 and y2 intersect at E or 17 over whatever is the case. But right now I can see that it is not intersecting. There is no such real solution for x0, implies there is no such real solution for the intersections of y1 and y2, which would assert that y1 and y2 will never intersect option number A. Is that clear? Okay. So okay. So now let us think about let us just revise our concept of homogeneous differential equations, and especially of order 0. Homogeneous differential equation of order 0. Now, what are homogeneous functions? Let us first understand that. So a function is said to be homogeneous, and let's say I'm taking a order 2 function. Let's say I'm taking a function of 2 variables, that is f r2r is said to be homogeneous if if uh, if f of lambda x lambda y is equals to lambda ki power n f of x comma y, where n belongs to some natural number, n belongs to some integer. Okay, so a function is said to be homogeneous function, and obviously this lambda x and lambda y should be that it must lie in the domain of definition of f. So let's say the domain of definition of f is given by df, then a function which is defined from domain of definition of f to r, where domain of definition must be some subset of r square. These are all the things. Then f of lambda x comma lambda y should be equal to lambda ki power n f of x comma y. Let us take an example and understand this thing. So if I say that my f of x is equal to x square plus 2xy plus y square, this function is a homogeneous function of degree 2. This function is a homogeneous function of degree 2. Is it clear? You can clearly see if you replace lambda x and lambda y, what you'll find that lambda square x square plus 2 lambda square xy, and then you will have this plus lambda square y square, and if you take lambda square common, so you'll get lambda square x square plus 2xy plus y square, and that will give you lambda square f of x comma y. So this is how it is. Is that clear? So these are called as homogeneous functions. Now, if you are solving a differential equation, which is like dy by dx equal to f of xy, dy by dx equal to f of xy, and f of xy is a homogeneous function, then this differential equation is called as your homogeneous differential equation. This differential equation is called as your homogeneous differential equation. And we will be most of the times we will be doing what? We will be doing homogeneous differential equation. And most of the times we will be concerned about the functions whose degree is 0, like whose order is 0, or you can say order, which degree would be right term to use. Degree 0. Okay, so the order degree would be a better term to use. Have I written somewhere order? Okay, so fine. So if let's say for example, I'll take an example and then we'll solve it. For example, if I'm giving you dy by dx is equals to minus of 2x plus y divided by x, and let's say it is minus. So you can clearly see that here also, if you this particular function on the right hand side, if you replace x and y by lambda x and lambda y, what you will get? So this function 2x plus y upon x is a homogeneous function of degree 0, isn't it? It is a homogeneous function of degree 0. Just what you have to do in order to check it, just replace instead of x and y, lambda x and lambda y. So if you replace lambda x here, so if I replace lambda x comma lambda y, what I will get? I will simply get lambda raised to power 0 f of x comma y. This is something that you can check it on your own. Okay, so it is a homogeneous function of degree 0. So what is the methodology? Most of the cases you'll find that the methodology is just to place y over x as b, and if in case it is defined as dx by dy, So in case it is defined as, for example, instead of writing dy by dx, if I write dx by dy, then I will write x by y equal to, and all this particular substitution we have to do. And there are several other like other methods also. For example, if it is not homogeneous, then we can reduce it to homogeneous form. But for most of our cases, and mostly in examination also, they will not ask you that level of question, because that is like very tedious approach. Although we shall discuss it in some time, but overall understand this will be the most of the times you'll get this kind of thing. Is that clearer? I'll do all those questions also, but I'll only give you a hint there. I'll not solve it entirely. That is the equations which are only reducible to homogeneous form. For that, what we do, I'll let you know. But overall, understand this is how you solve a homogeneous differential equation by appropriate substitution of y by x equal to v. And if it is given by dx by dy, then you have to replace x by y as v. Is that clear?
Yes,
हाँ
sir.
भैया
Okay, so let us do a question that was asked in TIFR examination in physics only. Okay, so this was asked in TIFR 2015, and simple question it is: the function f of the function yx, the function yx satisfies the differential equation given by x dy by dx equals to y, and then you have this ln y minus ln x plus 1. Okay, and given that y1 equals to 3, it was asked what is the value of y3. It was given that y1 equal to 3, and it was asked y3 is equal to what. So let us try to solve this differential equation. This was asked in TFR, how to go about it. So you'll find mostly in examination, you will not find equation reducible to homogeneous form. You'll find mostly the convenient differential equations. Okay. So what I would do, I would try to put this x here. So I'll get dy by dx is equal to simply y over x here. And inside I can write it as ln y over x. And then I can write it as plus 1. So one can see that this particular thing, this entire particular thing, that is y by x and ln y by x plus 1, it is a homogeneous function of degree 0, isn't it? That is easy to find, that this, if you replace x by lambda y, sorry, if you replace y by lambda y, replace x by lambda x, this would be like lambda ki power 0 here. Here also you'll have a lambda ki power 0, and overall you can find that this is a homogeneous function of degree 0. So what is the way ahead? You just take y by x is equal to v, and if you take this, you'll get dy by dx is equal to v plus x dy by dx. Is that clear? I hope it is clear. So what I can do, I'll replace on the left hand side this particular thing, that is v plus x, and then I will write dv by dx, and this will be like v here, ln v here, and then again v here. So if you replace it by v, this is, so v gets cancelled, and this is like now in variable separable form. What you can do, you can put your, you can take this in denominator, you can take it there, so that respective functions of respective variables, respective differentials will be accompanied by respective variables. So like dv would be accompanied by this function 1 upon ln 1 upon v ln v, and this will be accompanied by x. And now if we integrate it both of sides, what I'll get, I'll simply get, if I take ln v as some t, this will be like 1 upon v dv dt. So this will be like ln of ln v. I hope this is an easy integral for you at this stage. And there would be some constant, let us write ln k. Okay, so what I can do, I can write my ln v is equals to some kx, and initial, otherwise I can place that and otherwise I can write my v, that is y on x is equal to e ki power kx, and simply y as a function of x, I can write it as x into e ki power kx. Is that clear? Now, if I already know that y1 was given as 3, so I'll write y1, and it was given as 3, it will be equals to what? E ki power k, and this will be like, if e ki power k was given as 3, so so the second parent, like this particular thing, I'll rewrite it as y as a function of x is x, and I will simply write e ki power k into x. Now e ki power k is given as 3, so y ki power y as a function of x is x into 3 ki power x. Is that clear? I mean, this is simple exponent way. So e ki power kx, I can write e ki power k and whole power x. So this will be it. And it was asked in the examination, what will be the value of y3? So what will be the value of y3? Y3 would be 3 raised to power 4, that is 81. Okay, is that clear? I think these questions are fairly easy for you. I mean, इसमें तो कोई दिक्कत नहीं होनी चाहिए, I hope. Is that clear?
Yes, sir.
Okay, yes. No, mostly such questions are only asked in your examination. So as much as I see your examination part, I mean, these are the questions that they are going to ask you mostly. Okay, mostly they're going to ask you these questions. So let us do a few more questions on this homogeneous differential equations. And again a question in TFR. Okay. It's not that key. I'm not going to do a TFR question, quantum mechanics. I'll do there also, but we have just started there, right? And I will insist I've already done Dirac delta function. So if you people get done with that, then we'll discuss PYQs on one day, so that at least your entire concept gets refreshed. So that is what is my suggestion to all those who joined new. So at least if you were not there in the complete lecture, at least if you can go through the Dirac delta function videos, and then I'll discuss those questions. So you'll be able to get the grip of the topic. So it was given the solution for the differential equation dy by dx equal to y 1 plus y by x minus y square upon x square, with the boundary condition that y is equal to 0 at x equal to 1, okay, is given by. So instead of giving you options, options में दे देता हूँ. Meanwhile, you start doing this question. These are the options. Okay, so I hope it is easy. I think it is fairly easy. We'll be able to do it. Don't worry. Okay, so how to go about this problem? That is solution for differential equation, and this is the differential equation. How to go about it? Okay, so again, this is you can see that this is clearly on the right hand side, the function given to you is a homogeneous function of degree 0. So what I'll do, I'll simply replace y is equal to y by x equal to v. So y is equal to xv, and this is like v plus x dv by dx. These are very standard things. Once you are into the practice, then you will be able to write it as soon as I write the question. So this will be it. And now everything is quite clear that what you have to do, you have to simply put the you have to use this variable septal form, integrate on both ends. I hope you remember this formula. Even if you don't, as I right now don't know the formula, what I do, I basically do this thing. I think plus I have. So like integral 1 upon 2 and integration this. So even if you don't remember this, I think this is easy to see that this would be this. Okay, I mean, if you want to do partial fractions, good enough. And if you remember the formula, it is more then it's better. Like if you remember this entire formula, I don't remember those formulas, so I do in this manner. So 1 upon 2, this will be like ln of 1 minus v plus ln of 1 plus v. And why negative? Because here it was a negative, so negative would come here by the reversing the chain rule. And this is like ln x plus ln k. Is that clear? So eventually I'll get ln of 1 plus v upon 1 minus of v is equals to 2 ln x, sorry, ln k. Okay. So overall, this will give you, I think this will be like x plus pi, and this is y, and here you will come x minus y is equal to x square into k. Is that clear? Okay, you write y by x here, you write y by x here. This is something that will get. Now, already given to you was that at x equal to 1, your y was 0. So replace x equal to 1 here, y equal to 0, x equal to 1, y equal to 0, x equal to 1. So you'll get that your k is equal to 1. And once you get your k equal to 1, all you are required to do is you have to just extract y from here. You have to just extract y from here. So extracting y from here, what I'll get, x plus y is equal to simply x cube minus x square y. Replace it here. So you'll get x cube minus x, and here you have this y, and this is 1 plus x square. If you take it there, so y as a function of x, you will get x into x square minus 1 divided by x square plus. I hope it is clear. So the answer to this thing should be, the option number 1 should be an answer to this, right? Is that clear? Is that not clear? Is that clear to you?
Yes.
Okay, so all these questions are quite easy. I think you will be able to do all these questions. I mean, these are not difficult questions as such. If you try to solve these questions, you will be able to. So my idea regarding this, what you have to do is you just take any basic textbook of mathematics, like any advanced engineering mathematics textbook, try to do as many as questions as possible. At least in each of these varieties, I would say, do 5 questions. You know? So for example, 5 questions for homogeneous differential equation, 5 questions for first order, first degree. And if you do all those things, then you will be able to get everything. Because see, if you're not doing any question, then like right now everything is working. But once you are on your own, then you will not be able to do anything. So that is what I'm trying to say. That if you really want to do good, at least expect that this particular thing is going to be asked. So this particular topic is going to be asked. I think okay, this particular topic in any way is going to be asked. Now let us do a few more questions on first order, first degree. And now there's a question on something called as your Bernoulli's form. Okay, so what do you do in Bernoulli's form? So if instead dy by dx plus py, you are given not q but q y raised to power n. So what is the standard approach? You divide this y raised to power n. So you divide this y raised to power n throughout. And now you take, let us take y की power 1 minus n as some t. If you take this up, you will get 1 minus n y की power minus n dy by dx as simply dt by dx. And like, so dy by dx into 1 upon y की power n, you will get 1 upon 1 minus n dt by dx, and all other things follow. So you replace this here. So if I replace this here, I'll get 1 upon 1 minus n dt by dx, and I will get plus p into t is equal to q. So you'll get this particular linear differential equation form in t, and once you solve it for t, you can replace y की power 1 minus n, and all those things otherwise will follow. So let us do one of the questions again asked in GATE examination in mathematics, and let us do that. So consider the differential equation. Consider the differential equation given by dy by dx is equals to ay minus by square, such that a and b are greater than 0, y0 is equals to y0. As x tends to infinite, the solution yx tends to, okay. So this is what it has been asked in the examination. A is 0, option number B is simply a by b, option number C is simply b by a, and option number D is simply y0. Okay, so what has been asked? It has been asked that dy by dx equal to a by minus b by square, where a and b are both greater than 0, and y0 equal to y0. As x tends to infinity, yx tends to which of the following values? This is what it has been asked in the exam. So what I'll do, I know this particularly, I can write this as dy by dx minus ay is equals to minus of by square. So what I'll do, I'll replace this up. So what I'll do, I'll divide this entire thing by minus 1 upon y square. So if I divide it by minus 1 upon y square, so minus 1 upon y square dy by dx plus a by y, I'll get simply b. Is that clear? So if I divide it by minus y square all through, this is something that I'll get. And now here I can replace, I'll take let 1 by y is equal to t. If I take 1 by y equals to t, minus 1 upon y square dy by dx will be minus, this will be simply dt by dx. I think this is clear. If you differentiate on both sides, you will get this. Okay, and remaining one is a into t is equal to b. And if you solve this differential equation, what you will get? This differential equation will be like e की power ax into t is equal to integration b into e की power ax dx, and simply you'll get t e की power ax is equal to b upon a e की power ax, and then you have this some constant of integration, let's say c1. And you know that y0 is given as y0, so I'll use that condition. So y0 at x equal to 0 is given as y0. So I'll write what is t. So t is 1 upon y. So 1 upon y0 e की power 0 is equal to b upon a plus c1. So c1 I will simply write it as 1 upon y0 minus b upon a. Now replace this thing here. And what I will get, I will simply get 1 upon y e की power a is equal to b upon a e की power a x plus 1 upon y0 minus b upon a. So this is what I'll get. And if I write it in more better form, so I think 1 upon y will be b by a plus 1 upon y0 minus b upon a whole raised to power e की power minus ax. Now it was given already that a and b are positive constants. It was given that a and b are positive constants. Already it has been given there. Okay, already it has been given. See, here it is. Here it is. Now you were asked that how would your yx behave as x tends to infinity. So let us take the limit x tends to infinity 1 upon y of x. So this will be like b upon a here, and this entire term will become 0 because e की power ax, and here it is a negative sign. So a is accompanied by negative sign. X tends to infinity, this entire term will go to 0. So this entire term will not be there. So 1 upon yx as x tends to infinity is b by a. It implies limit x tends to infinity yx would be a by b. Is that clear? ये चीज समझ में आ गई? ये चीज आई नहीं है, समझ में आ गई बेटा? Okay, so all these questions I hope everybody has got, and mostly we'll do this entire thing using these questions only, and that is why I'm placing this thing in basic mathematics section, because all of these concepts and mostly you've done in your differential equation classes either in standard 12th or in BSc general. Okay, so most of these concepts are not so advanced, and I'm not using any sort of physics here. So differential equation we'll take a single lecture all over again. That will be more on the physics side, and that I'll do in mathematical physics section. This is all basic mathematics, so I'm not. I believe that this will be fine. I mean, is this clear? Like, by question wise, you're able to get it now. So your thing is that at least you start doing questions from your HK Das or whatever book you have right now. At least 5 questions of each type. For example, we have done today Bernoulli's form. Try to do 5 questions. Just 5 questions. I'm not even saying unsolved. Just solved ones, so that at least you get how to do it. Otherwise, you'll not be able to even pick up your pen in the examination. So that is a big dream. So in next lecture, I'm going to do a little bit big problem that was asked in net examination. So I am having a lack of time right now, so I'll do it in the next class. So next class is just following. Okay, so kindly join that particular session.